In this video, we are going to review quadratics. Graph these equations on your graphing calculator at the same time. What happens? Why? So let's go ahead and go over to Desmos.com, and I'm just going to type in those four equations. So I have x minus 3 times x plus 1. For equation 2, I have x squared minus 2x minus 3. For equation 3, I have x minus 1 squared minus 4. And for equation 4, I have x squared minus 2x plus 1. So if I hide the blue one for now, and then I had the red and I had the black, I'll see here that these first three equations are all the same. It's just this last equation that is slightly different. So I could say something like, let's see, the first three equations produce the graph of the same parabola. These equations represent the same function written in different forms. So if you think back, this first equation right here, this is written in factored form, also known as intercept form because it gives you the x-intercepts. This second equation is written in standard form, ax squared plus bx plus c. And this third equation is written in vertex form. This fourth equation produces a different parabola. And this one is written in standard form as well. So if I go back and we look at the next example, it says below are the first three equations from the previous problem. These three equations all describe the same function. What are the coordinates of the following points of the function? From which equation is each point easily determined? Explain. So this is factored form again, or intercept form. This one is standard form. And this one here is vertex form. And the first thing they want to know is the vertex. Well, we can easily see the vertex from vertex form. Vertex form is y equals a times x minus h squared plus k. And to find the vertex, you look at h and k. You change the sign of h, and you keep the sign of k. So again, this is visible from vertex form. If you weren't sure, by looking at the equation, you could go back and look at the graph. And you can see here that this graph does have a vertex at the point 1, negative 4. Next, they want to know the y-intercept. And I can find the y-intercept easily by looking at the second equation. Remember, your y-intercept is where your graph crosses your y-axis. That means x is 0. So if this is 0 and this is 0, all that's left is negative 3. So the y-intercept is a point 0, negative 3. This is visible from the second equation in standard form. And then our x-intercepts, we have two x-intercepts, and I can see those right here from our factored form. So if I have x minus 3 times x plus 1 equals 0, I can set each of those factors equal to 0 and solve, giving me positive 3 and negative 1. So I'll have the ordered pairs 3, 0 and negative 1, 0. And this is visible from factored form. Which was y1. Down here it says, make up an equation for a quadratic function whose graph satisfies the given condition. Use whatever form is most convenient. Now there is an infinite possibilities for each one of these. I'm just going to give you one example. You might come up with a different example and they can both be correct. So on example 1, it says has a vertex of negative 2, negative 5. To me, this is most convenient to use vertex form. And so I know that I want this to be h and this to be k. So it doesn't matter what a is. You could have a be whatever number you want. I'm going to keep this simple and leave a as 1. So I'll have x plus 2 squared minus 5. So if you were to graph this in Desmos, you would see that this does have a vertex of negative 2, negative 5. Remember, you change your sign of h and you keep your sign of k. Example 2 has a y-intercept of 6. To me, this is most convenient by using standard form. It doesn't matter what a or b are, c just has to be positive 6. So I'm going to say y equals 2x squared plus 3x plus 6. Remember, to have a y-intercept of 0, 6, if I plug in 0 for x here, I'm going to get 0 plus 6. That's going to give me a y-intercept of 6. If you're not sure, use Desmos. Example 3 has x-intercepts of 3, 0, and 5, 0. To me, this would be most convenient using factored form, also known as intercept form. And so I could say y equals x minus 3 times x minus 5. If I were to set each of these factors equal to 0 and solve, I would get 3 and 5 as my solutions. Has x-intercepts at the origin and at 4, 0. Well, remember your origin is 0, 0. And so here we would have x equals 0 and x equals 4. Again, this would be most convenient to use factored form. And so I'll have y equals x times x minus 4 as an equation that would have those two solutions. Again, if you're not sure, you could 100% use Desmos to help you figure this out. Let's go to the back page. It says an object is launched directed upward at 64 feet per second from a platform 80 feet high. This can be modeled by the equation s of t equals negative 16t squared plus 64t plus 80. What is the object's maximum height? When will it obtain this height? To find the maximum height, you're going to look at the vertex, and that is going to be the y-coordinate. So the y-coordinate of the vertex is going to be the height, and then when it obtains this height will be the x-coordinate of the vertex. So there's lots of different ways that you could do this. You could recognize that this is in standard form and use negative b over 2a to find your x-coordinate of the vertex and then plug that in to solve for the y-coordinate. Or you could use Desmos, and that's what I'm going to do. Now, Desmos doesn't know what the variable t represents here, so I'm going to replace that variable t with x. So I'm going to have negative 16x squared plus 64x plus 80. And remember, you can zoom in and zoom out, whatever you'd like to do. And I'm just going to click on that vertex. That vertex is at the point 2, 144. So that means that the maximum height is 144 feet at 2 seconds. On the next example, it says Franco and Grace each throw a baseball vertically into the air at the same time. Franco throws his baseball while standing on a cliff so that the baseball lands on the beach below. Grace throws her baseball into the air while standing on the beach. The table gives the initial velocity and initial height of each baseball at which each baseball is thrown. So here is our equation that we're going to be plugging into. So they tell us that Franco's initial velocity, V naught, is 32. So I'm just going to replace V naught right here with 32. So I'll have h of t equals negative 16t plus 32t. And that his initial height, h naught, is 48. Grace, they tell us that her initial velocity, V naught, is 64. And that her initial height is 3 feet. So again, all I did was replace V naught with their initial velocity, so their initial speed, and I replaced h naught with their initial height. Part A says, at what height above the ground does the baseball leave Franco's hand? They tell us that Franco's initial height is 48 feet. At what height above the ground does the ball leave Grace's hand? Well, they tell us that Grace's initial height is 3 feet. Now, if you're more of a visual person, you could just plug this into Desmos. So let's do that. Again, Desmos doesn't know what t is as a variable, so we'll have to use x's instead of t's. So Franco's equation is negative 16x squared plus 64x, plus 32x plus 48. And Grace's equation is negative 16x squared plus 64x plus 3. Now with these ones, if we zoom out, it's kind of hard to see. So what I recommend you do is come over here to this little wrench that's over all the way here on the right. So here we have home, the minus, the plus, and then the wrench. And then I'm going to change my x-axis. I want the smallest x value to be 0. And I want my largest x value, well, this is probably not going to go past 10 seconds. You could try 20 to start, kind of look at that. When I change it to 20, I can see it doesn't really go past 5 even. So like, let's just do 8 so I can get a more zoomed in area there. And for my y's, I'm going to start at -2. I know that I can't go below the ground and I can't have negative numbers, but giving some negative numbers there will just make it easier for me to click on my x-intercepts. So I'm going to have that be negative. And then it looks like this it's not going to go past 80, so I'll type in 80 for that. Now, again, that's not required to do this. It just helps me see better what's happening on my graph. You could just zoom in and zoom out as needed. Or again, you can come up here and you can play with that yourself. That's completely your choice and your preference. So if you weren't sure, you could click on these y-intercepts. And so maybe I'll do the same thing with my x's. Let me just add a negative number there to make it easier to click on. And so now I can click on that y-intercept of 0.48 and this y-intercept of 0.3. So if you weren't sure by looking at your chart or looking at your equation, you could just find the initial heights right there on Desmos. Part C says, what is the maximum height of Franco's ball? So the maximum height is going to be the vertex. Franco's ball was the first one, so that's in purple. His initial height is 64 feet. Sorry, not initial height, his maximum height. So Franco's maximum height is 64 feet. Part D says, when does Grace's baseball reach its maximum height? Well, Grace's equation is the second one, so that's the black one. Her initial height, or her maximum height is 67 feet, but they want to know when, and so her maximum height happens after 2 seconds. So again, this one was asking for the maximum height. This one wanted to know what time we reach the maximum height. And then part E says, which ball hits the ground first? So here we have, this might be better to see if I change this back to a 0. So here's the graph of what's happening. Franco's ball goes up into the air and then lands after 3 seconds. And then Grace's ball, Grace's ball here starts at 3, goes up, comes back down, and lands after 4.05 seconds. So which one hits the ground first? That's going to be Franco's ball.